one of the things that our old textbook liked to do to trick you on a monomial, which I thought was pretty insightful, is they'd give you a problem like this. And at first glance, do you see how it looks like two terms? Do we agree that looks like two terms?
Yeah.
But they're like terms, so what can I do? Add them, so it's really 7x. And now, do we agree that's truly one term? It's a monomial. So you want to make sure you simplify anything you can simplify first. Most of them don't simplify. They give it to you in standard form a lot of the time, and it's simplified as possible. But when they don't, you do need to simplify it. So how many terms do you think for a binomial? 2 terms. And then trinomial? 3 terms. So often when we go about naming things, we give things 2 names, kind of like you have a first and a last name. So typically when we go through to name stuff, we're going to name it not only based on the number of terms, but also the degree. So let me show you an example of what I mean by that. So let's say we have x cubed plus 2x. So think back to section 4.1. What degree is that? 3. If I use my words, it is linear, quadratic, cubic, quartic, quintic. Cubic. So we would call this a cubic, how many terms? Binomial. So typically, when we name our polynomials, they get a first and a last name, just like we have a first and a last name. They don't get a middle name, but they get a first and a last name. And again, the first name would be based off the degree. The last name would be based off of how many terms. Now, let's say you have 4 terms, or 5 terms, or 6 terms, or 100 terms. Anything that is 4 terms and up. So I'll say 4 terms plus. We just call those polynomials. Again, I just kind of picture some mathematicians hanging out together and like, let's name stuff. And then, like I said, I picture them getting hungry or taking a nap or something because they started naming, they were doing great, and then they were like, yeah, I'm done now. I don't want to name anymore. Maybe they ran out of names. I don't know. But this is where we stopped. So anything 4 terms and up, we just call a polynomial. And sometimes we get even more specific, so we'll say it's a 10-term polynomial or a 5-term polynomial. Does that make sense? So we say how many terms there are in it. Okay, let's come down here, look at some more examples. It says, determine whether each expression is a polynomial. So this is kind of coming back from section 4.1 as well. And then we are going to state the degree of the polynomial. And let's also name it. Let's name it too. State the degree, and we're going to name it with a first and last name. They don't get middle names. All right, look at A. Polynomial? No. Why?
The root.
The square root. We've got a variable under it. Now, if there was a 2 under it, that'd be fine. A variable under it means it is not a polynomial. So not a polynomial. Okay, go to part B. Is it a polynomial?
Yes.
Yes. So it is a polynomial, so that's good to know. Polynomial, check. It is one of those. If it is a polynomial, then we want to state the degree. What is the degree? 3. It's the biggest exponent. So it is cubic. So when we go to give it a name, it is a cubic binomial. Good. Cubic binomial. All right, ooh, the next one's kind of tricky. I don't think we've talked about degrees when we've had multiple variables. It's not much different than what we've been doing. It's not much trickier. First of all, is it a polynomial? Yes. You can have multiple variables. That's fine. Polynomial. Check. Okay. When you are looking for the degree and you have multiple variables, you're going to start by totaling things up. Do you agree if there's no exponent with the a, there's really a 1 hiding there?
Yeah.
Okay. So if I add those two together, this would be 3. If I add the 2 and the 3 together, I would get 5. This is a 1 and a 1, so I would get 2. Which number is the biggest? 5. So my degree is going to be 5. So when you have multiple variables, you add the exponents together and then pick the biggest. Just like we were before. We're always picking the biggest, but we have to add first. Hold on, let's name it. Let's name it. If it's degree 5, it is quintic. And there are 3 terms, trinomial. Because of the 3 terms. Okay? All right, go ahead and flip. So we've got some like terms that we are going to add and subtract, and then some stuff that we're also going to multiply. It is literally just this easy. I almost feel like it looks like a trick today. Like, are you tricking me? Is this really what the math is? No, it is. I think the thing that gets people most is with examples like, I don't know why it says 2 through 3 and then it's got ABC, but I think that's probably the most confusing part of today's lesson. Examples 2 through 3, ABC. I think the thing that gets people the most is they see 2 sets of parentheses, and what's your gut instinct with 2 sets of parentheses? Multiply. But look what it's telling you to do. Is it really telling you to multiply? No, it's telling you to please add. All right, so we're going to go through and find like terms. I really don't even need these parentheses, like they are literally helping no one. So let's go through and find like terms. I have a 2x cubed. What goes along with my 2x cubed? Who's its buddy? X cubed. All right, I've got a plain old 9. What goes along with my plain old 9? 4. I've got, I'll circle this one. I've got a negative x. Who is negative x's buddy? 7x. And then I notice I have this 5x squared. Does 5x squared have a buddy? No, bummer. All right, I'm going to put my answer down and I'm going to write it in standard form. So I'm going to start with the biggest exponent first. What was the biggest that I came across? 3. Okay, so let's combine them. If I have 2x cubes and somebody gives me one more, how many x cubes do I have?
3.
3x cubes total. Okay, let's go to the x squareds. Nothing to combine with this, right? So we're just going to write it on down. Then x to the first is next. If I have negative x plus 7x, what do I have? 6x. And then I go to the numbers. 4 and 9 give me 13. So I think one thing to think about here is just how you're going to combine your like terms. I like to underline and circle stuff so it makes it evident to me what I can combine and what I can't. You could also use a highlighter. You could also even line things up vertically, kind of like we did back when we first started learning how to add and subtract. And so if you line things up vertically, that sometimes helps too. I think I might do that with the next one. All right, this one I actually do need the parentheses. Do you see how there's a minus in front of this one? So I'm subtracting this whole thing. So I'm going to distribute that minus through to everything. So it applies to all the things that are in that set of parentheses. All right, I'm going to start with my first set of parentheses, and I'm going to put stuff in standard form. Do you see how I have a negative 2x squared? I'm going to leave a little bit of space, and then I'm going to put a plus 3. So now it's in standard form, right? So I just rewrote the first set of parentheses in standard form. I left an awkward amount of space, gave it its bubble, and then I put the plus 3. Okay, come down here. This is going to become a negative x squared. This is what I mean when you can set it up vertically. Do you see how, like, if you line up the like terms, sometimes that helps? This is going to become a negative 6. What should I line the negative 6 up with? The 3. And then this is going to become negative becomes a positive x. And positive x doesn't have a buddy, so it's going to kind of go in that middle spot where there's nothing else. If I have negative 2x squareds and I subtract one more, I have x plus nothing, x. 3 and negative 6, -3. So this would be my final answer. So again, I don't care how you set it up. Do whatever works best for you. It's almost like a counting moment. Like what's going to work best so you set it up and don't make a mistake. Like that's what I want. All right, let's distribute our negative in the next one. Boom, boom, boom. And I'm going to freeze my board. I want you to do the problem. I'm going to do the problem, and we will meet back up and talk about what our answer is. So you try it, and I'm going to try it. Okay, you ready to see my answer? Ta-da! Is that what we got?
Yep.
Perfect. Okay. Now, if you look at the next examples, which are labeled 4 through 6, and then A through F. I got nothing, you guys. We'll work on that for next year. We'll make those match up better. For the next examples, do you see how it literally is multiplication? Like these were actually addition and subtraction, even though we had 2 sets of parentheses. These we have some sets of parentheses, but it truly is multiplication for us. Okay, so let's multiply. And the first one is, the word I would use is distribute, right? So if I have 4y squared times another y squared, what do I have? 4y to the 4th. If I have 4y squareds and I triple it, what do I have? Squared, yes. I don't like how low my 4 is. Remember, that's an exponent. I don't like where it's living. It's a little down low for my liking. Okay, that'd be my final answer. So 4y to the 4th plus 12y squared. Part B, if it's asking me to square something, what is it really telling me to do? Multiply. So I'm taking this, but what am I multiplying it by? Itself. If it was cubed, how many of these sets of parentheses should I have? 3. Okay. So the little exponent is telling you how many sets of parentheses I need. So let's FOIL. 3r times 3r gives me 9r squared. 3r times -7. Yeah. -7 times 3r. -21r. Yeah. And -7 times -7? 49. And so typically when you multiply in this order, your like terms will be there in the middle together. So I've got 9r squared minus what? If I combine like terms, yeah, minus 42r plus 49. So that'd be my final answer. And I always love answers boxed in when we're doing problems like these so I can tell what your final step of work is. Like, show me what your final answer is. Okay, I think you can FOIL the next 2 without me. Try them. I'm going to freeze. You're going to try them, I'm going to try them. And then we're going to meet back up and talk about it. Ooh, we picked up an additional variable with part D. We can still do this. We've got it. Okay, so just do C and D and then stop. Remember, when you have multiple variables, typically when we write those, we write them in alphabetical order. So even if we picked up like a third variable or a fourth variable, we typically write all of them just in alphabetical order. Am I going to mark you wrong if you don't? No, that's not the hill I die on. However, typically that is how we write it, is in alphabetical order. So get an answer for both. Do you need a note worksheet? What do you need it from? Do you need a note worksheet? Yeah. We're multiplying. We're doing a little foiling. All right, are you ready? Spoiler alert, here they come. How'd we do? Good? Okay. Let's look at the next two. So the next two aren't much different, but there are more terms. So we've just got to be a little bit more careful and pay attention to details. I am very particular. I'm sure you've learned that about me by this point in the year. I like to have the smaller one first. Now, you don't have to do this, but I like it better. Right? So I'm having one of those only child moments where we're going to do it my way because this is the way I like it. All right. This one's even harder than the next one. See, the next one, it has fewer terms. All right, 2c times 5c to the 5th. 10c to the 6th. So remember, you add your exponents, you multiply the coefficients. 2c times 2c squared. 4c cubed. Yeah, I agree with that. I'm going to put it over here. And I'm going to put a 4c cubed. I'm going to do a vertical line up for this one, kind of like I did with some of the addition and subtraction ones. All right, 2c times negative 8c. Negative 16c squared. 2c times 4. 8c. All right, let's go and send the negative 3 through next. So this is going to give me negative 15 c to the 5th. Well, that doesn't have a buddy. That's a bummer. What's this going to give me? Negative 6c squared. So I'm going to line those up. What's this going to give me? 24c. And then negative 3 times 4, negative 12. And I used my space for part F. Oh, well. All right, we've got 10c to the 6th minus 15c to the 5th plus 4c to the 3rd. Notice I'm not adding or subtracting anything yet because do any of those have like term buddies? No. Now I get into some like term buddies. How many c squareds do I have? Negative 22, yeah. Negative 16 minus 6 more, negative 22. How many c's do I have? 32c. And then we have our minus 12. That's a long one. All right, I think I'm going to go do F at the bottom so I've got more space. I'm going to freeze mine. I'm going to have you do F by yourself. And I'm going to do F by myself, and then we're going to talk. And I'm going to flip the order again. I'm going to put that y plus 3 first, and then the y squared minus 7y plus 5 second. Okay, so you multiply. I'm going to multiply, and then we're going to discuss life. Are you ready? Okay, don't look till you're ready. Spoiler alert, here it comes. How'd we do?
Good.
Good? So everything picked up a y the first time through when I multiplied by y, and then everything picked up a bonus times 3 the second time through, and then I combine my like terms. Again, you can write them all horizontally and add them, subtract them together. That's all it is. It's that easy for today. Are you ready for homework? We are on assignment number 3, page 237, numbers 2 to 26 evens. I will put my book under the board momentarily. You should have enough time to finish this before you go so you can have kind of a free and clear weekend of math. Right? You've got about 30 minutes. That's plenty of time. Plenty. We didn't have homework to go over today, so we have lots of bonus time to do our homework in class. I think I already told you guys.
Here's your rest of the
Yeah, go ahead.
Thank you.
Yeah.